All right, this is your section 7.3 recap video. So the rejection region, or critical region, is the range of values for which the null hypothesis is not probable. If a test statistic falls in this region, the null hypothesis is rejected. A critical value, T0, separates the rejection region from the non-rejection region. Finding critical values in a t-distribution. First, we have to specify the level of significance, alpha. 2, decide whether the test is left, right, or two-tailed. 3, sketch a t-distribution, draw a vertical line at each critical value and shade the rejection region. Number 4, find the critical values. If the hypothesis test is left-tailed, then we use tin.v, alpha, degrees of freedom. This is going to give us a negative, but that's what we want because it's left-tailed. Right-tailed, we use 1 minus alpha, degrees of freedom. This should give us a positive. And for a two-tailed test, we have to do alpha divided by 2 because there's 2 of the tails, and then our degrees of freedom. Decision rule based on rejection region. To use a rejection region to conduct a hypothesis test, calculate the standardized test statistic T. If the standardized test statistic is in the rejection region, then reject H0. If it is not in the rejection region, then fail to reject H0. All right, so here, if a left-tailed test, we're going to reject H0 if it falls in here, and we're going to fail to reject it if it falls in here. For a right-tailed, we will fail to reject if it falls in here, and reject if it falls in here. For a two-tailed, we will fail to reject if it falls between these two, but if it's in these areas, then we are going to reject H0. So let's practice. Find the critical value T0 for a left-tailed test given alpha equals 0.05 and n equals 21. So I'm going to slide this right over here. It's a left-tailed test. So what I'm going to do is I'm going to pick my tin.v. So I'm going to go over here and pick this. My probability is 0.05 and n is 21, so my degrees of freedom is 20. And as you notice, I get 1.7247. Let me make that just a little bit bigger so maybe you can see it. Which is exactly what we have got over here. And because the test is left-tailed, the critical value is negative. All right, why don't we find the critical value for a two-tailed test? So for this one, we're going to use the same function. We're going to go down here, tinv. Now, this time we have to divide our 0.05 by 2 because there's two areas where we can reject them. So we're going to have 0.05 divided by 2, and our degrees of freedom in this case is 26 minus 1, which is 25. And notice we get negative 2.059, which is the same thing here, and we just make this positive for this one. Because the test is two-tailed, one value will be negative and one value will be positive. All right, 2, a t-test for a mean mu. T-test for a mean, a statistical test for a population mean. The t-test can be used when the population is normal or nearly normal. The test statistic is the sample mean x bar. We can use this right here to find our test statistic. There's x bar minus our mean divided by our standard deviation divided by the square root of n. The degrees of freedom in this case are, as always, n minus 1. So let's find an example here. A used car dealer says that the mean price of a 2005 Honda Pilot LX is at least $23,900. You suspect this claim is incorrect and find that a random sample of 14 similar vehicles has a mean price of $2,300 and a standard deviation of $1,113. Is there enough evidence to reject the dealer's claim at alpha equals 0.05? Assume the population is normally distributed. All right, so first we have to know our H0. And in our case, we want to find out the claim. You suspect the claim is incorrect and find that the random number of samples has a mean price of this and a standard deviation of this. So that is less than here. So if we go here, we're going to do our prediction. It's less than that amount. So our H0 has to be opposite of that, which is greater than or equal to that amount. Our alpha in this case was 0.05, our standard deviation 1113, and a random sample of 14 similar vehicles. So we have that. We can do 0.05. 14 minus 1 is 13. So now we need to figure out if our test statistic falls in our rejection region. So here's 0.05, and we can find out our test statistic by going back and using Excel to find 0.05, comma, 13, using that tin.v. Now we're going to plug it into our test statistic. We know our mean here. It's 2,300. It says that in the problem. We know what the salesman told us the mean was. We know the standard deviation, and we know our sample size is 14. When we calculate this, we find a test statistic to be 3.026. Our decision is to reject H0. At a 0.05 level of significance, there is enough evidence to reject the claim that the mean price of a 2005 Honda Pilot LX is at least $23,900. Because we're rejecting because it falls within this bubble. It is to the left of negative 1.771. If it were to have fallen over here, we would have failed to reject. Let's try this again. An industrial company claims that the mean pH level of the water in a nearby river is 6.8. You randomly select 19 water samples and measure the pH of each. The sample mean and standard deviation are as follows. And we're going to put those on the next slide. Is there enough evidence to reject the company's claim at alpha equals 0.05? Assume the population is normally distributed. All right, so H0 is equal to 6.08, and we're testing if it is not. We're at a 0.05 alpha. There was 19 people in our sample, so degrees of freedom is 19 minus 1, which equals 18. We're going to draw a rejection region. This is a two-tailed test because it's equal to and not equal to. So we had to divide by 2 and get our test statistic to be negative 2.101 and positive 2.101. Now let's find our test statistic. We know from the problem that we're doing 6.7 minus 6.8 divided by a standard deviation of 0.24 divided by the square root of 19. That gives us a test statistic of negative 1.816. Now where does it fall? If it falls in the blue, we reject. If it falls in the middle, we fail to reject. This one falls in the middle. So our decision is fail to reject. And our conclusion is, at the 0.05 level of significance, there is not enough evidence to reject the claim that the mean pH is 6.8. And that is it for this section.